Sorry for the technical issues at the beginning. I am Matthias Klum. I will talk about AppStream and Listaller today. First of all, some boring stuff about me. Who am I? I am a PackageKit developer, Debian developer. I contribute to KDE and GNOME, and I'm the current Listaller maintainer, and I maintain AppStream together with Richard Hughes. I also started the Tangloo project last year together with other people. But now to the more important stuff. What will the talk be about? First of all, I will identify the problem. What are we going to fix with AppStream and Listaller? And then I will talk about AppStream, then about Listaller. I will probably make this a bit quicker so we have some time for discussion in the end. And then at the end, I will draw a conclusion about both projects. First of all, we need to know what is wrong with application management to understand why we need AppStream. First, the content of the distribution software repositories is usually displayed in form of packages, but this is not very user-friendly because every non-technical user finds tons of packages where some have names which he or she doesn't understand, and also he doesn't understand why there are so many packages and what are development packages for. And if you just want to install Firefox, for example, you easily get lost in the package management. Also, the existing software centers are distribution specific, and basically every new distribution would duplicate the effort of creating a software center, while a software center is an application which displays applications instead of packages. So compared to an app store if you want. Also, the applications are not very well represented to the user because right now we have only the desktop file as metadata source and an icon which is usually associated with that. But no additional data. For example, localization is often missing. Not on Debian, we do very well with that, but other distributions don't have that. There are no screenshots or bad screenshots, and there are lots of inconsistencies between distributions because every distributor writes its own description for every single application, every single package. Also, there's no interaction possible from the side of the user with the software center. For example, it would be really cool if the user could give a rating, a review for new software, or if he could just report a bug within the Software Center user interface. Because if he just tried the application and it didn't work for him and he found a bug, it's the more natural way to report it. This is about the application management, but there's also another issue, which is application distribution on multiple Linux distributions. The current situation is that we have PPAs, personal package archives, at the Ubuntu world, and repositories for every other distribution to get new software. But for third-party applications, these are really insecure because they can break distribution upgrades if you have a third-party third-party repository enabled, which packages an application differently, and then the distributor also packages that thing, but also slightly different. And then the user wants to upgrade his system, he might easily break it due to conflicting packages. Also, there are scripts inside these packages which are executed by root, so with root permission. So if you install the application, you can't be sure that it won't execute malicious stuff during installation before we can sandbox it. Also, handling of PPAs is not very user-friendly right now. Ubuntu does some work on that, but it's still not perfect. Also, the PPAs are distribution-specific. If I want to package a third-party application, I have to create one repository for every distribution, and in the RPM world, almost one RPM package for every distribution. Also, they have a complex structure because they are made for package distribution and not for distribution of applications, which is what we are aiming for. That's another solution to install third-party stuff, which is binary installers, but these don't integrate well. They are not user-friendly, and they execute lots of stuff with root permission if they need to be executed as root. So we need a simple and secure cross-desktop installation solution for third-party applications which are not yet packaged by the distributor, who might not have time to backport everything. So this has spawned two independent projects. One is Appstream, which is which mainly contains cross-disto specifications for building Software Center and Software Center-like applications, which includes lots of metadata, a database spec for distributors to access to get information about what applications are available in the package database. Also, they include some optional new metadata for upstream projects to ship, so we can enhance the available data to represent an application in the Software Center. They also offer the interactive features I spoke about before. Listaller, on the other hand, generates cross-distro application packages. It contains tools for app developers to make applications available for many distributions. And it contains also a metadata specification to describe dependencies on Linux distributions. It is an optional component, so if you don't want to, you don't have to ship Listaller. And it requires PackageKit, so if you ship Listaller, you should make sure that PackageKit is available. So first talk about Appstream. Appstream was first created in 2011 by these people from Fedora, Debian, OpenSUSE, Mageia, Ubuntu, KDE, and some free desktop developers. They sat down together and discussed how we could collaborate, how we could do a collaboration in order to create a really good-looking Software Center which is available on multiple distributions, so not every distribution has to redo all the work again to make a Software Center happen. So this resulted in the Appstream concept, which starts with a so-called compose server, which scans all the packages which are available in the repositories, extracts desktop files, icons, and app data. I will come to app data later. Then generates a large XML file containing all this metadata and all translations, which gets compressed and shipped to the client together with an icon pack. The client then aggregates data from multiple sources. One is the stuff which came from the compose server, but also stuff from a screenshot server, from a feedback server, and other possible sources to display the application to the user. In more detail, the desktop files and package files are converted into a Xapian database for additional features like easy stemming and faster access to the information. Yeah. The key of Appstream is the so-called Appstream XML, which contains all information about the application, which is the name, a unique application ID, so we can identify it on the system and we can ensure that there are no duplicate applications, which is right now the desktop file name, a summary, a description, icon, author data, project group, which is, for example, GNOME or KDE, so we can filter applications. If you don't want GNOME applications, you can say no GNOME, or if you don't want KDE applications, you can say no KDE. You can also create different departments for that. So Mozilla is also a project group. Categories, which is available in desktop files already. MIME types, so you will be able to create a query for an application which is able to open or to process a MIME type which you don't know, which is also a useful feature for users who get a file which they can't open. So they will just ask the Software Center, how can I open that? Keywords, pretty self-explanatory, and screenshot references and description. So we have every application can have multiple screenshots, which also contain a small description on what the user can see on the image. It also contains a few other things which are less important. There are a few issues with that which we experienced after writing the Appstream XML, which is that it also allows localization. But there are a few issues we noticed after writing it. Surprisingly, some people don't like XML, which was a bit embarrassing for me because I first created that XML together with the others, and then I wanted to implement that in Debian, but I got people told me that XML is used nowhere in the infrastructure, and so Debian prefers YAML for that instead of XML. So we created a new a Debian extension project called Deb11, which will enhance not only which will enhance metadata in Debian in general. It will contain the upstream data, but also data about additional components like like codecs or themes or whatever you want to find in the packaging database. So it's a little bit more than just the upstream XML. The other problem is that where do we get data from if the distributions don't have it in their repositories already? So if we can't extract it from the desktop file, or if it is not already available in the description. The second problem is addressed by the so-called app data. App data are also small XML files which are shipped with upstream projects. They are a subset of the upstream XML specification. They contain URLs to third-party servers which contain the screenshots. So this is where we get screenshots for upstream from. They are localized upstream, so we have one description which has a localization which we don't have to redo again and again on every distribution. There are no requirement to implement upstream. This is where we had some confusion about because Fedora said that they would drop every application which doesn't have an app data file from their software center, from GNOME Software. But this is a distributor's policy. So upstream is perfectly fine without having an app data file. It will just not display that much data about the application. So it is desirable to have an app data file in an upstream project. So if you ship a GUI application, please provide an app data file for it. Yeah. External content, like screenshots, if it is on third-party servers, like I said before, is prone to be broken soon because the upstream server might go down, or there might be malicious stuff even in there, and they might change it afterwards to something else. So the distributor, on creating of the upstream XML pack, will download the screenshots, cache it on its own server, and modify it if necessary. So the distributor still has control over that, but yeah, at first the information lays on the upstream server. And some statistics about the app data. Yeah, there's not that much to say, but what is really interesting is that GNOME already ships over 50% of its applications with app data because they simply made it mandatory to have app data, while there's only one KDE application with app data. So KDE really has to catch up there. I am drafting something which might enable having easy upstream on KDE as well. There are currently some issues with translation, but I'm pretty sure that we will fix that in time. For XFCE, I still need to find the right people so we can talk about adopting app data if they want to. I also mentioned another issue before, which is that we have two file formats, one YAML format and one XML format. And that's also because Ubuntu was first and did it differently, an Ubuntu format which also contains app information, which we want to have for software centers. So you also have to have fallback solutions for screenshots, etc. So it's getting a little bit more complex, at least during the transition phase where not everything is in the upstream XML format. So we invented libupstream, which is like a common library every new software center can use to access this information. This will avoid that every software center has to reparse the XML file or the YAML file or the Ubuntu app install information, or has to download the screenshots has to detect the screenshot server, download the screenshots from there, and also consider a fallback solution if the distribution offers one. So this libupstream stuff generates a Sapien database, which contains all the data for software centers to access. So the software center will basically only see the database and not the raw data it was generated from. Also, libupstream allows accessing the database via IG object interface because many people were afraid of using the native Sapien interface, and gobject allows creating bindings for almost any programming language out there. This is how it looks like in the end. We have an upstream plugin which runs inside the package kit daemon, so it will listen to refresh actions on the PackageKit daemon, and if it receives a refresh action, it will check if the AppStream data is up to date, and if it is not, pull the data from Ubuntu app install, from Debian Deb 11, or from AppStream XML, which all other distributions ship, and then generate a Sapien database. As you can see, it also acquires information from different sources, and the clients, if they want to, can access the Sapien database directly, so they don't have to use libAppStream. So what about AppStream adoption in GNOME? GNOME software was created last year, which now is the only really fully AppStream compatible software center out there. It's fully supported in Fedora. It's pending on OpenSUSE, as far as I know, and on Debian, it's blocked by the Deb 11 implementation, which just needs some more time. On KDE, we have Upper, which is the KDE PackageKit frontend, which aims to be both a package manager and an application manager, so to combine both worlds. Upper has some initial support for AppStream via libAppStream, but that needs some more work because it's not working as well as we wanted it. So there are some issues. App data inclusion into KDE projects is something we discuss right now there, and I also heard about a possible port of the Muon Discover stuff to PackageKit and AppStream. So I think there was a lot of people working on that, at least one Summer of Code project, if I remember correctly. On the distribution side, on Debian, I already talked about Ubuntu has their app install, which came before AppStream, so it's not a not invented here syndrome this time. It will likely migrate to Debian solution, but we will see what happens. Fedora is Fedora. They were pioneers on the AppStream front and shipped that stuff first. And OpenSUSE has working AppStream XML, but I'm not sure if it's used productively. Last time they were still ironing out some issues in the generation process. So far, unfortunately, only GNOME has a software center which supports everything from the AppStream specification. So this is about the application management part. So now I come to the application distribution part, which is Listaller's domain. First, some background about the project. It was started in 2008 as an experiment. It was first never intended to be used productively anywhere. It covered some features of PackageKit and AppStream that time. It has its own package management abstraction layer, just as PackageKit has, and it had some metadata extension, just like AppStream has, but much simpler. Because of that, it switched to PackageKit in 2009 for communication with the native package manager. Then later it merged with Autopackage. I'm not sure if you remember Autopackage. It was started way before Listaller was created and shipped binary packages. But then development slowed down, and later it merged with Listaller. And we adopted some of its features and some of the projects which were created inside Autopackage. AppStream was then started in 2011, so this part of Listaller was also obsolete. So we rewrote that thing from scratch, which took almost a year. And now it only focuses on the distribution part, which it does, in my opinion, really well. Listaller's main goals are integration with the system. So we don't want that the user has another installation GUI to install an application, while there already is a user interface, which is the software center or the PackageKit application installer. Also, we don't want a second updater. So if you update your system, if the user updates their system, it should be a one-time thing. So he has one update here where he updates all applications and not the second one like on Windows. Also, installed applications should look like native applications, but they should not be treated as native applications. So they run in a sandbox, have different privileges, but because they come from a potentially malicious source and were not checked by the distributor. Obviously, cross-distro and desktop compatible. it should be simple because we don't aim for a catch-all solution with Listaller. It should install applications, but that's it. It should not install stuff like an init system or install toolkits or everything which has reverse dependencies. Because this is the domain the native distribution package management is working in, and where it makes sense to have it, while Listaller is designed only for applications. It should be secure, which means we have security, a security hints database, signatures, and a sandbox, which is currently under construction. We also ship some developer tools, which are basically help us to generate a statically linked application, or to make it relocatable, or to do some automatic QA, like checking all the validity of all file formats used in the application. The basic concept of Listaller is that it is a PackageKit plugin, which explains the integration part. Because every application which talks to PackageKit will also automatically talk to Listaller, because it sits as a plugin inside PackageKit and catches all the Listaller packages which are passing through and processes them before they reach the native backend in PackageKit. If you don't know about PackageKit, PackageKit has different backends to talk to the native distribution package manager, and Listaller just sits in between them. Well, therefore, as I said, every PackageKit client is able to install Listaller packages. Also, this is the connection to Upstream. Listaller drops some XML into the XML pool of Upstream, which results in a really great representation of every Listaller installed application in the software center. So if the XML is present, it will be automatically processed by the tool which generates our Sapien database for the software center, and therefore the software center will know that will map the Listaller package to the application information and display it to the user so he can uninstall it, for example. Also, Listaller uses a superset of the app data spec as source for application metadata. So every Listaller package will also include an app data XML file. So if we are going to install the application, we can already show information about what the user is currently installing. As you might imagine, Listaller consists of many tools to achieve that. It has some end-user tools which manage, for example, a database of trusted keys, so the distributor can set which sources are trusted and the other ones are untrusted until the user adds a key manually. It ships some developer tools to generate portable applications to link against an older glibc version, for example, or to simplify static linking. It also contains some tools to track dependencies and to visualize them. It also contains the obvious packaging tools like libpkgn, which is the Listaller package generator, and a small QA tool which will, for example, validate XML files which were shipped with the application, or check if the desktop file's integrity is okay. So distributors don't have to worry much about Upstreams creating crappy packages, because the packaging itself is damn simple. The Upstream can't do much wrong with doing that, and the other stuff is checked by the QA tool automatically, so we can already see common mistakes. It's just like Lintian, but less powerful, unfortunately, so far. So if you create a package, it's a utopia package creation. So really the simplest way to create an Upstream package, if everything, a Listaller package, if everything works as intended, is that you have to write your app data description, then write a small options file, which basically just defines if you want to make Listaller automatically detect all dependencies in your source tree, and which version of the Listaller package you want to create. Then you need to write a file directory listing for the new package. Listaller will later decide where to install that application based on distributor's policy on that, but you need to create the directory structure for the application by yourself using some placeholders for the final path with Listaller, which Listaller will insert during installation. then you can already build the package because there's a small tool included which will detect your build system and handle the installation part. It currently does not work with many build systems, so you can still give Listella all the required information to build the application, or you can just point it to the binary stuff and package that. So you don't have to build the package build the application during the package creation process. Yeah, this is, I will skip that. Later the package is GPG signed, so any package which is not signed will be rejected for installation unless the distributor has lowered the policy to allow dangerous package installations. So you can expect a Listella package to have a signature. And yeah, during installation, Listella will process all files installed by the package and also do some modifications if necessary. For example, adjust paths in desktop files, or well, do almost anything the distributor finds useful in order to integrate that application. Right now, it's really only take a look at desktop files if they are sane and if they are in the right location. Yeah. So I now talk about dependency solving, which might confuse you. Also, no presentation without a cat. Because at the beginning I said Listella should be simple, and dependency solving is one of the most complex things, at least for if you aim to be cross-distributional as well. So why have this dependency solving if it's so painful to do it? Well, mainly if we statically link everything into one binary, we not only use more memory because we have to load all that stuff, but also if the distributor, for example, pushes an update to the toolkit, which closes the critical security-sensitive bug, it will not reach the third-party application, which also ships that toolkit. So it is a potential security risk, which we don't have. So it makes some sense to have at least a base level of dependency solving for major dependencies. For example, system components like glibs or toolkits. So yeah, the main problems here is that we want to simplify that the distributor might not provide enough metadata for Listella to find the dependency in the native distributor database. So in that case, we can't install an application if a dependency is missing. And also, what do we do if the ABI of the dependency is not stable? For example, if they decide to make some changes without bumping the so name, and well, the application just can't use it. And also, what do we do if we absolutely require an old library version? Well, the answer to the last question is obviously statically link it. For the ABI stuff, there is no real solution. We simply rely on upstream projects to take care of that and don't break the ABI unless it's really necessary. In order to enhance the metadata about available dependencies in the distribution repositories, we created the so-called component files, which simplify dependency solving. I will go a bit faster here. Components are, for example, toolkits. I already explained that. And to install a Listella application, Listella only needs the basic stuff. So all small dependencies which don't ship a component file and are not available on multiple distributions should be included directly in the package. They don't necessarily need to be statically linked. You can flag that thing as a library, and Listella will take care that the application can find it later after it was installed. Last but not least, Listella can, in theory, also satisfy dependencies by downloading a statically linked package from third-party sources, which might not be wanted by the system administrator, so he can disable that. Listella can also check CPAN, CRAN, PyPy, or the gem library in order to satisfy dependencies of Python stuff, for example. So what is component information? Component information can be compared to a non-developer package config file. It describes all the component version and all the public interfaces it provides, which are, for example, libraries or binaries, but also stuff like icon sets or other data which is used by other applications, other than the project itself. So everything which is shared should be defined here. Later, we can then, during the package creation process, map the dependencies we found in the applications to a component. Tell the user, well, you are shipping stuff here which does not have a representation, a component representation on the distribution, so you might want to statically link that or to include it there. And we can also check on which distributions the application will run, because we have this information and we know which distribution ships it, so we can run a check like your glib version, glib dependency is too high to run on Ubuntu 14.04 or something. Yeah, it also allows dynamic dependency detection, dynamic version detection, sorry, which means that if we ship the component definition with the package itself, we can, on the users, on the target system, check if the dependency is installed without having to query the native package manager. Well, I already talked about that. As said before, we shipped that DAPScan tool, which is able to perform that task and to not only detect dependencies of binaries, but also Python models and yeah, almost anything when you ship with the application. Yeah, I'm sorry for being faster here, but some discussion time would be wanted. The future of the Stellar is to first finalize and formalize the Stellar specifications, because some stuff does not have documentation yet, although it's getting better, and we want a formal standard for creating the Stellar packages, so others can review that and check if it's satisfying their needs. Also, it will result that in a stable package standard, so we won't break the packaging stuff anymore. Upstream projects, at least some, should ship component definitions by default, so we are able to send a query to the native distribution database. For example, install me GTK 3 bigger than 3.12 in version. This is not only helpful for the Stellar, but also for projects which compare versions available in multiple distributions, because we can just check for component definition files and then map them between distributions and detect which distribution has which version. It also will allow us to get rid of horrible stuff like the Valve developers did with Steam. They ship a small script called SteamDeps, which is heavily dependent on Debian for detecting dependencies. If we have component definitions, Steam could just ship a package-kit-based file, which is able to find all the stuff they need from third-party sources in the distribution's own repositories in a cross-distributional way, without being dependent on Ubuntu or Debian. Of course, the Stellar should go into more distributions. It's already shipped in some, but the coverage is not really high so far. And maybe in the end have a way for third-party developers to target all Linux distributions with one app package, because it's really desirable for upstream projects to have one thing the users can download or access from a single source, and yeah, then have it. Then creating for one package, one native package for every distribution, or cramming together some weird binary stuff. Conclusion about all projects. Well, I skipped that because you heard it just recently. We welcome contributors to Upstream and to Stellar because there are currently very few people working on it, and it would be great to get more feedback and to get more people involved. It's not the most, apparently for some people, it's not the most interesting field to work in, but I can assure it's an awesome place. And we are all nice people. Conclusion about writing free desktop stuff, which we experienced, is that we should never do things leading to the impression that we want to force stuff coming from GNOME on KDE or coming from KDE on GNOME. It sounds natural, but it's really easily done to talk in a way that it sounds to people that they would get stuff which was developed for GNOME and then is dumped on KDE with the argumentation, well, it's a standard, please implement that stuff. Why? Because it's a standard. So yeah, we have to take everyone with you if you want to succeed with something. On the contrary, sometimes you need someone to just go ahead with the projects and have the others follow. The upstream stuff was stalled for a very long time, unfortunately, because there were not enough people working on it, and there was some stuff missing. We had some issues with the canonical CLA, for example, to get the software center available on multiple distributions, which in the end failed. So GNOME software was created, but it was just too late. And we also needed Fedora to really push for upstream in order to make it happen on more distributions. Also, it does not make sense to invest too much time in bike shedding about details in the same manner. So you should just go ahead with implementing something, and users will complain about that later, and then you can adjust it. So instead of debating about hypothetical stuff beforehand. So that's it. And do you have questions?
I've got a microphone up here, so folks who have questions, let's use this so it ends up on the video. We'll take questions in order of row, so if you're down here and you forget your question, we're not coming back.
One question, does the linstaller package provide a post-install, pre-install hooks, like Debian packages, for example?
It provides, the package itself is not able to run any script because we execute it with root permission, and therefore we don't want, at least not during installation phase, that the packager is able to execute any script. Which is happening is that the installer will scan what is available in the package and then decide what is the best thing to do. For example, if it ships a desktop file, it will later update the desktop database. So it is doing that, and if the person who created the installer package wants to do something which he or she would need a script for, they could just file a bug against the installer, and we will implement that for every other person as well in the installer directly.
Thank you very much for the upstream. It's really, really needed. As an upstream developer, I tell you, we need some tools that protect us from distribution maintainers to actually fuck it up. So it's the opposite, point of view. My question is about this DEP11, I think it's called, like this new universal Debian thing. What is? Can you tell us more about this process that is ongoing? I kind of read on your slide.
Well, it's a Debian thing. DEP is a Debian extension project, and this file will include information about components, so the component data I talked about on the installer side, but also information about the applications and stuff like codecs or kernel modules. So we can, if something is missing, if an application misses a module which would be necessary to work, for example, if you have a video converter which needs to convert something, but some GStreamer module is missing to do that, it can make a package-kit query on to find out which package provides the missing component and can afterwards install it. So what we do with DEP11 is to push all this metadata into one file and make it available on every distribution, on every Debian distribution using apt and enabling this feature, which it is just for Debian. The file format is independent. Of course, everyone can use it, but yeah, the thing is mainly about Debian. I'm currently working on implementing that stuff in the Debian Artiv kit, so I hope this will get ready soon.
Do we have one more question? We have time for one more. Okay, great. Thank you very much. Very good, thank you.
Thank you. I was way too fast. I was way too fast, though.
No, you were perfect. I think that people, so like most people, the rate of speed you talk when you're talking to most people is way slower than they can take in information. People tend to get bored. So if you talk quickly during a presentation, people actually like that because they don't get bored. So I thought it was great.
Yeah.
So. All right. Yeah. show you this real quick.
Yeah.
There's not a lot to it.
I didn't think so.
Assuming nothing breaks it now.